Now we'll take a look at linear regression and correlation. Professionals often want to know how two or more numeric variables are related. For example, is there a relationship between the grade on the second math exam a student takes and the grade on the final exam? If there is a relationship, what is the relationship and how strong is it? In another example, your income may be determined by your education, your profession, your years of experience, and your ability. The amount you pay a repair person for labor is often determined by an initial amount plus an hourly fee. The type of data described in the examples is bivariate data. Bi for two variables. In reality, statisticians use multivariate data, meaning many variables. In this chapter, you will be studying the simplest form of regression, linear regression, with one independent variable x. This involves data that fits a line in 2 dimensions. You will also study correlation, which measures how strong the relationship is. Up to this point, you've used single-valued or univariate data. This lesson introduces bivariate data, which are 2 related values of data. Examples include height and weight, like 72 inches, 200 pounds, the year a person was born and life expectancy, so 1950, 65 years, your grade on a second math exam and your final exam, education and income, etc. You will learn the basics of how to determine if there is a linear relationship between the 2 values of the bivariate data by understanding the concepts of linear regression and correlation. Linear regression for 2 variables is based on a linear equation of the form y equals a plus bx, where x is the independent variable, y is the dependent variable, and a and b are constant numbers. Typically, you choose a value for the independent variable x and solve for the equation for y. The graph of a linear equation of this form is a line that is not vertical. Let's take a look at the following example. Y equals 3 plus 2x. So by substitution, if x equals 1, then y equals 5. X equals 0, then y equals 3. If x equals negative 2, then y equals negative 1. We can plot those points, 1, 5, 0, 3, and negative 2, negative 1, and construct a graph as shown here. For the linear equation y equals a plus bx, a is the y-intercept where it crosses the y-axis, and b is the slope of the line. The slope b describes the steepness of the line. Remember the rise over run formula from your algebra days? The y-intercept is the y-coordinate of the point 0a where the line crosses the y-axis. See the examples at the right and what they look like. The most common way to display the relation between 2 variables x and y is a scatter plot. A scatter plot is just points plotted on an xy graph. The following graph is a scatter plot. A scatter plot shows the direction and the strength of a relationship between the variables. A clear direction happens when one of the following is true. High values of one variable occur with high values of the other variable. Low values of one variable occur with low values of the other variable. High values of one variable occur with low values of another variable. If the points appear close to a line, a power function, an exponential function, or some other known function, then there is generally a strong relationship between the variables. It is the overall pattern and any deviations that are important in a scatter plot. We are interested in scatter plots that show a linear pattern, a line, particularly a strong one.